Welcome to the Logical Galaxy. In this video, we are going to explore about the concepts related to the integers and float numbers in the Python. Now let us dive into the discussion. Integer arithmetics. When we talk about arithmetic operations with numbers in Python, we're usually dealing with addition, subtraction, multiplication, and exponentiation. Division in Python always gives us a floating point number, which means a number with a decimal point, even if the result could be a whole number. For example, when we divide 17 by 3, we get 5.6666666667, which is a float. Similarly, dividing 20 by 4 gives us 5.0, still a float. Exponentiation, represented by double asterisk, is used to raise a number to a certain power. So, 2 raised to the power of 4 is 16. That's straightforward. But what if we have a negative power? Like 2 raised to the power of -3. In that case, it's like saying 1 divided by 2 raised to the power of 3. So, it's 1 divided by 8, which equals 0.125. Python handles negative powers just like positive ones, so you can write 2 raised to the power of -3 and get the result directly. So, in summary, Python's arithmetic operations work as expected, and even negative powers are calculated correctly. Integer division. Here, Python offers 2 types of division for integers: regular division, which returns a floating point number, and integer division, which discards the remainder and gives you the whole quotient as an integer. Let's take 17 divided by 3 as an example. With regular division, you get 5.66666667, but with integer division, you get 5 because it discards the remainder. Now, the remainder itself can be obtained using the modulo operator. So, when you divide 17 by 3, the remainder is 2. To summarize, regular division gives you the result with decimals included, integer division gives you the result without decimals, and the modulo operator gives you the remainder of the division. All these operations return integers. Very big and very small numbers. Absolutely. Python allows you to represent very large or very small numbers conveniently using scientific notation. For instance, if you want to express a number like 3.9 billion, you can write it as 3.9e9. Here, the e stands for times 10 to the power of. So, 3.9 multiplied by 10 raised to the power of 9 equals 3.9 billion. When you run this code in Python, it outputs 3,900,000,000.0, which is indeed 3.9 billion in standard notation. This makes handling extremely large or tiny numbers much simpler and more readable in your code. Round and round. When you want to convert a floating point number to an integer in Python, there are a couple of ways to do it. One way is to use the int function, which simply removes the fractional part of the number, essentially rounding towards 0. So, int 1.3 gives 1, int 1.7 also gives 1, int -1.3 gives -1, and int -1.7 gives -1. However, if you want to round the number to the nearest integer, Python provides the round function, which performs the rounding we're familiar with. So, round 1.3 gives 1, round 1.7 gives 2, because it rounds up, round -1.3 gives -1, and round -1.7 gives -2, because it rounds down. These functions offer flexibility depending on whether you want to simply truncate the decimal part or round to the nearest integer. They help in handling floating point numbers more conveniently in your code. Floats can confuse you. Floating point numbers in programming languages like Python can sometimes lead to unexpected results due to the way computers store and represent them. This is because of limitations in hardware precision. For example, when you add 0.1 and 0.2 in Python, you might expect to get 0.3. However, due to the way floating point numbers are stored and handled internally, you actually get a result like 0.300000000000004. This is a result of the inherent imprecision in representing floating point numbers on a computer. While this discrepancy might seem small, it can sometimes lead to unexpected behavior in calculations, especially when dealing with financial or scientific computations that require high precision. It's important for programmers to be aware of these nuances when working with floating point arithmetic and to use techniques such as rounding or using specialized libraries when precise calculations are necessary. Math Module. Python's Math Module provides a wide range of mathematical functions for working with floating point numbers. Before you can use these functions, you need to import the Math Module into your program using the import math statement. For instance, if you want to find the smallest integer not less than a given number, also known as the ceiling value, you can use the math.ceil function. This function takes a floating point number as input and returns the smallest integer greater than or equal to that number. In the example you provided, after importing the Math Module, you can use math.ceil to find the ceiling value of 4.2, which is 5. Similarly, math.ceil 1 plus 3.8 evaluates to 5 as well. This module is quite handy when you need to perform complex mathematical operations or calculations involving floating point numbers. More ways to import math. Python also allows you to import specific functions or variables from a module using the from, import, syntax. This way, you can directly use the imported function without referencing the module name. In the example you provided, you imported just the ceil function from the math module using from math import ceil. This means you can use ceil directly without prefixing it with math. So, in the code x equals 7 divided by 2, x becomes 3.5. Then, ceil x is used to find the smallest integer not less than 3.5, which is 4. Hence, the output of the code is 4. This method of importing can be particularly useful if you only need a specific function or a small subset of functions from a module, as it allows for more concise and readable code. Absolute value of a number. The abs function in Python returns the absolute value of a number, which is the distance of the number from 0 on the number line, regardless of its sign. This function doesn't require any imports because it's a built-in function in Python. So, when you pass a negative number to abs, it removes the negative sign and gives you the positive value. For example, abs minus 6 evaluates to 6, as the absolute value of minus 6 is 6. Similarly, for positive numbers, the absolute value remains the same. For instance, abs 3.81 returns 3.81, and abs 0 returns 0 because the absolute value of 0 is 0. The abs function is handy when you need to ensure that you're working with positive values, regardless of the input's original sign. Some more functions from Math Module. The Math Module in Python provides a variety of useful mathematical functions for working with floating point numbers. Here's a brief explanation of some of the functions and constants you mentioned. Floor of x returns the largest integer less than or equal to x. For example, math.floor 3.8 returns 3. Ceil of x returns the smallest integer greater than or equal to x. For instance, math.ceil 3.2 returns 4. sqrt of x returns the square root of x. For example, math.sqrt 25 returns 5.0. Log of x returns the natural logarithm of x. For instance, math.log 10 returns approximately 2.30258509299446. Log of x a returns the logarithm of x to the base a. For example, math.log 110 returns 2.0. Pi, mathematical constant representing the value of pi, approximately 3.1415926. E, mathematical constant representing the value of Euler's number, approximately 2.71828. Sin of x returns the sine of x in radians. Cos of x returns the cosine of x in radians. Tan of x returns the tangent function of x. Asin of x returns the arcsine of x in radians. These functions are handy for a wide range of mathematical calculations, such as trigonometry, logarithms, and more. They are particularly useful when you need to perform complex mathematical operations in your code. Please do subscribe Logical Galaxy for more tips and tutorials.